Okay. So every quadratic looks like this. It's either a bowl that curves up or down. It has a vertex, which is its lowest or highest point, and an axis. That doesn't seem too hard. Can we determine these vertices and these axes? Axii? Axi? What do you think it is? What is it, Amelia? Axi? It sounds. I'm recording this for Mason, so Mason, we are gonna wait. What? Plur. The. Is that a word? Is that? That is plural. It looks weird when you write it down. The plural of axis, we don't know. So come back and tell us tomorrow. Mason will know. Can we find the vertex and the axis? Let's keep it in singular form. Yes, we can. And it was something that second period loved to do. They really did. Here is the standard form of a quadratic. Seen this before, Amelia? Good. Was it at Governor's School? Was it at Hogwarts Academy? This is the standard form of a quadratic. The general form is the one that you're used to because you factored it tons of times. It's the like 2x squared plus 4x plus 5. That's the general form. The standard form is this. And the standard form of a quadratic is very similar to different forms of linear equations. Like you had standard form of a linear, you had point slope form, you had slope intercept form. And the thing with all those forms was once you made the equation look like that form, you could just pull information out of it. Like if you put a linear equation in y equals mx plus b form, you could just pull the slope and the y-intercept right out of it. So that's what happens with this. So if you happen to be given something that looks like this, you will rejoice because this is already in standard form. And you can read information right out of there. Like you could say, hey, I know where the vertex is. That's x minus h. The vertex is at hk. So I can read into this and I can say, well, that is at 3, negative 5. And the axis is a vertical line at x equals h. So I can also say that the axis is at x equals 3. And I could graph it pretty easily too. And draw a coordinate plane. I say, hey, this is something squared. From the day we did translations, we know that this looks just like x squared, except it's been moved to the right 3 and down 5. So I can go over to the right and down 5, and there is my vertex. And there is my parabola. I tried to make it steeper than the normal x squared because it is doubled, but I'm not a very good drawer. So we rejoice if we get one like that. It won't be real often because most of the time we will get it in general form and it'll look like this. Oh no! So we have to undertake what I think is a simple process when it's broken down into its parts, and the second period thought it was an exceedingly complicated process, not unlike calculating the path of a rocket around the moon or something. I mean, They just thought this was death incarnate. Okay, but we don't, because we have Amelia, and if it gets too hard, she will cast a spell. We'll flash her a little picture. Can't wait to put up the little picture. It's the highlight of my day. Okay, this does not look like a number times x minus something squared plus something. It doesn't look like that at all. So we're going to have to do some things. And the first thing we're going to do is we're going to group the x's. Now it looks a little bit more like it, right? Doesn't it, Sarah? Now it's got parentheses. The standard form has parentheses. We've made a step in the right direction. I'm going to group x's, and the other thing that we do not want any coefficient with dx. So I'm going to have to factor this coefficient out. So I'm going to group the x's, and factor out any coefficient that's there. Okay? So if I take a 2 out, that leaves me with x squared plus 4x. Agreed? You agree with me, Sarah? Okay. All right, what is next? Okay. We are going to do some magic here. And I would have said that even before this thing with the wand. I want to go off to the side, and I want to look at some things. Let's see. This is the unrelated scratch work section. X plus 3, the quantity squared. I need more room. I'm going to go down here. Sorry. All right, x plus 3, the quantity squared. We know the shortcut to this. You square the first, you double the product. 3 times x is 3x, double that is 6x, and you square the last. So if you notice, if we were to take this trinomial and factor it, this number in the second spot is the square root of 9, but it is also half of 6. Right? And if I did x plus 5, the quantity squared, 10x plus 25, notice that the last number here is the square root of 25 and is 1/2 of 10. Okay? We're seeing this, right? So if I were to turn this right here, see, we want it to be x minus a number squared. Just if we want it to look like these on that side. So I want to turn this into x plus or minus something squared. So I want to turn this into a trinomial that will factor like that. So the question is, what would be missing? I want to factor this, and we know that the last number in the trinomial is the square of the middle, the square of the second, and it is also half of the middle. So what is half of 4? 2. And what is 2 squared? So I'm going to put 4 in there. Bartolomeo, you and your crew should be suspicious of that, because you can't go around like Johnny Appleseed just throwing numbers in functions and expect everything to be okay. You can't just do that. But what you can do is add 0. You can add 0 anywhere you want. So I'm going to take 4 away just to keep it real. I want to follow the rules, right? If Sarah had $10 and I gave her $4 and then I took 4 away, I really haven't changed the amount of money in Sarah's purse. If she carries a purse. Oh, she does. I see it.